We are going to learn one more important concept from statistics, which we use in a data science or in a machine learning. So that is a correlation. To understand the correlation, we have to understand the covariance also, what the covariance and how we calculate the correlation from this covariance. In our previous video where we discussed about the covariance and variance explains the spread of data from the mean or around the mean. And coming to the covariance, so where covariance we use two variables, whereas in variance we use only single variable, and with respect to that single variable we find out how the data points they spread around the mean, whereas the covariance which explains the relationship between the two variables, and also this covariance it explains how the relationship between the two variables, whether two variables are increasing together or they are decreasing together, or whether one variable is increasing when other variable is decreasing. So such relationship can be understood by the covariance. So the formula for covariance, if we see, so covariance of xy is equal to sum of xi minus x bar into y minus y bar divided by n minus 1. So in numerator where we take the sum of x minus x bar into y minus y bar, and we in denominator we have n minus 1. Okay, so how we calculate that covariance, that I explained in the previous video. When we calculate the covariance, we take the data points and we calculate the mean deviations for each variable. We calculate, so that means data point of each variable we calculate the mean deviations, and we calculate the sum of all the mean deviations for each variable, and we multiply them. That means the each data point in x we multiply with the each data point in the y after mean deviations calculation, and finally we get sum of that x variable and sum of y variable, and we divide that with n minus 1. Okay, so this is different from the calculation of the variance, where we know that we square the mean deviations, and we sum all the mean deviation square values. Okay, so the sum of square deviation values becomes the variance, and when we calculate the root for the variance, that become the standard deviation. So coming to the relationship between the variance and the standard deviation also, so when we take variance, since we square the differences, therefore to normalize that we take the standard deviation. That means what I mean to say, so when we take data units, so the data units when we square, so the data units will change to bring back to the normal values, or to scale down that square values. So the root calculations are formed on the variance. So that is one aspect. So the other one is the covariance, where we don't square the mean deviations. We take the only sum of the mean deviations. That is important. So even in the table where we can see that the first column which has the data points of x variable, and second column has data points of y variable, and in the third column where we can see the mean deviation of each data point, the values of mean deviation for each value data point in the x variable, and fourth column where we can see the mean deviations of each data point in the y variable. So in fifth column where we can see that we have sum of xi minus x bar and y minus y bar values, that we can see for each data point there we have x minus x bar and y minus y bar initially. So we calculate covariance of x and y variables by multiplying the mean deviations of both x and y variable. For each data point we have to multiply their mean deviations. So finally the sum of the mean deviations of each data point of both x variable and y variable gives us the covariance. For example, in this data we can see for the first data point of both x and y variable, the multiplications of mean deviations is 4, and for second data point it is 1, and the third data point is 1 again, and for fourth data point it is 9, and fifth data point it is 16. So
the sum of all the sum of the multiplications of the data points of both x and y variables in this case provides gives us 31. So that is the covariance of this the sum of the multiplications of both x and y variables of all data points. So to calculate the covariance, we have to divide this by n minus 1, so that we get 31 by 4, that is 7.75. It is a covariance. So the covariance range, so covariance provides a range from a small number to a big number, whereas correlation, the values actually from minus to 1 we find it. So why we get a range of values for covariance? Because we multiply mean deviations of each data point, we get the range from small value to the highest value high, so that we get a range of values for covariance, for uh, uh, whereas for the correlation we get the values from minus 1 to plus 1 only. Okay, so the 7.75, so whether we get 7.75 or 10 or 11 or 12, so what these values indicates that the relationship between the x and y variable, so how two variables they behave, like no, whether two variables are increasing together or whether two variables are decreasing together, or when one is increasing other is decreasing. So such a direction only is explained by the covariance. When we get 7 or 10, so that indicates there is a positive relation, that means both variables are increasing together. So okay, so to calculate the correlation, so what we need other than the this covariance, so we need covariance values to calculate the correlation. Apart from that, we need the standard deviation also. So to get the standard deviation, again you can see in this table where and in the sixth and seventh columns where you can see the mean deviation squares. So we know that to calculate the standard deviation we have to first calculate the mean deviation squares, and then from mean deviation squares we have to calculate the variance also. Okay, the difference between the covariance and this correlation is that in covariance we use only mean deviations, and to calculate the correlation we need standard deviations. So to find out the standard deviation we need a mean deviation squares. So some of the mean deviation squares of x variable becomes the standard deviation of sorry, variance of the x variable, and some of the deviations squares of y variable becomes the variance of the y variable. The correlation, so on numerator we take the correlation values, and on the denominator we take the standard deviation values of both x and y variables, and with this we can calculate the correlation. So the correlation value, since we are taking the standard deviations, so the data gets normalized or scaled down to the original units of the data points. Since we perform the squaring of mean deviations when we calculate the variance, and when we calculate the standard deviation from the variance. Okay, so to calculate the variance we perform the squaring of mean deviations. Therefore whatever the units we take, for example if we take the centimeters, when we square that, so the units also becomes that becomes a centimeter square, sorry. So therefore to bring back to their original units, or to scale to normalize the data, so standard deviation where we perform where we take the root, where we calculate the roots for the its variance values. So therefore in a correlation we get the values from minus 1 to plus 1, so where plus 1 indicates the strong, where we can find out the magnitude of relationship between the two variables. When we say when we get a plus 1 value, so that indicates that these values or these data points, that means all the data points they are very close to the this particular straight line, and also these all data points they present very close to the line, and also they present towards the upper side, or towards the right side. So when we say minus 1, so in minus 1 where they are present towards the downward region, and also the values are more close to the line region, on the line only. So this is how we calculate the covariance and correlation. So covariance, where we get the range of values, uh, since we multiply both x and y variables, whereas when we calculate the correlation, where we perform division by taking the standard deviations on the denominator, therefore the values comes down to their normal range. So therefore we get the values from -1 to the +1.